Hello everyone. Log into Hub, complete debrief 5C and attendance. You'll have like 8 minutes. Okay, let's move on to the next slide. Segment vocabulary. We will see few of the definitions in this particular slide. First one, segments of a chord. The segment formed when two chords intersect in the interior of circle are the segments of the chord. So what do they mean here is if I have a circle and these two are called as the segments of the chord. These are the segments of the chord. Secant segment, a segment that contains a chord of a circle and has exactly one endpoint outside of a circle. The one that I'm indicating it in blue is your secant segment on this circle. Supposing if I have, this will be a secant segment. Okay, this particular AB will be your secant segment. Secant segment is a segment that contains a chord of a circle and has exactly one endpoint outside the circle. So segment AB is your secant segment. External segment is the part of the secant segment that is outside of a circle. That is AC is your external segment. So AC in this particular figure is your external segment. And there is one more which is our tangent segment. The segment is the same as the tangent segment is from one endpoint outside the circle and all the way till point of tangency. Okay, so this was our secant segment, this is external segment, and this is tangent segment. These are few of the vocab terms which you all should keep in mind. So please don't down. I'll give you another 30 to 40 seconds and then we will move on to the next slide. Okay, let's move on to the next slide. We'll see the first theorem based on the segments of the chord. Segments of the chord theorem says that if I have two chords intersect in the interior of circle, then the product of the lengths of the segment of one chord is equal to the product of the lengths of the segment of the other chord. We had discussed this in our previous class. I'm reiterating and then we will see some more problems based on this. So if I have two segments which are the chords AB and CD, then EC times ED will be equal to AA times EB. To understand this, we will see some more problems. We had seen this in our previous class. So here I have in the first problem, I'll do the first one, then I'll give you a chance to work out second and third. Okay, on the first one I have 6 times x based on the previous theorem, because 6 and x belong to the same chord, equals 3 times 4. Okay, further dividing by 6 I will have x equals 2. Okay, same way all of you try the problem numbers 2 and 3. I'll give you exactly like a minute and a half and then we will go over the solution. Okay, let's go over the solutions for problems 2 and 3. So for problem 2, once again we have 23 times x equals 15 times 23 from the previous theorem. Now dividing by 23, I will have x equals 15. Let's try problem number 3. So for problem number 3, we have x times 12 equals 6 times of x plus 4. Let's further simplify this. 12x equals 6x plus 6 times 4, which is 24. Subtracting 6x on both sides, I will have 6x equals 24. Dividing by 6, I will have x equals 4 as the final answer for this problem 3. I hope this is clear. Let's move on to the next slide. We are seeing the next theorem, which is called as the segments of secant theorem. This theorem comes into picture whenever we have two secants intersecting outside a circle. If two secant segments share the same endpoint outside of a circle, then the products of the length of one secant segment and its external segment is equal to the product of the length of the other secant segment and its external segment. What does that mean? Here, if I have EB and EC as the secant segment, then the product.
Carney.
Okay, we were seeing this particular theorem. With regards to context of this particular figure, we can apply theorem as the product of the secant segment and the external segment. Means the external segment here is EA and EB is the secant segment. EA times EB will be equal to EC times ED. Okay. So note down this one as well. I'll give you 30 seconds, then we will see some problems based on these theorem. Okay, let's see a few problems based on this particular theorem. I'll do the first one, then I'll give you like a couple of minutes for second and third problem. Here I have two secant segments. One is x plus 3 is the length of the first secant segment. The secant segment times the external of that secant segment is equal to the other secant segment, that is 10 plus 2 is the secant segment. It's all the way from here till here. 10 plus 2 times the external of that secant segment, that is 2. If I simplify this, I get 3x plus 9 equals 10 plus 2 is 12, 12 times 2 is 24. So I have 3x plus 9 equals 24. Let's subtract 9 from both sides to get 3x equals 24 minus 9 is 15. Dividing by 3 on both sides, x equals 5. Okay, I want you all to try problems 2 and 3. I'll just give you like another couple of minutes, then we will go over the solution. Okay, let's go over the solutions for problems 2 and 3. Here the secant segment is 3 plus 5 for the first one, so 3 plus 5 times the external segment, that is 5, equals, for the second secant segment, the length of secant segment is 4 plus x times the external segment, that is 4. Okay, let's simplify further. 3 plus 5 is 8. 8 times 5 is 40. 4 times 4 is 16 plus 4x. Further subtract 16 on both sides to get 24 equals 4x. Then dividing by 6 on both sides, dividing by 4 on both sides, I get x equals 6. Okay, I hope this problem is clear. Let's see the next one. Here once again I have the secant segment, which is, for the first one is 6 plus 4 times the external portion of the secant segment, which is 6, equals, the other secant segment is 5 plus x times the external portion of this secant segment is 5. Let's simplify this further. 6 plus 4 is 10. 10 times 6 is 60. Equals 5 times 5 is 25 plus 5x. Okay. Further subtract 25 on both sides to get 5x equals 10 minus 5 is 5, and here 5 minus 2 is 3, 35, and dividing by 5 on both sides, you get x equals 7. Okay, I hope this is clear. Okay, I hope this is clear. Let's move on to next slide. Okay, one more theorem, the segments of secant and tangent theorem. Supposing we have a secant and a tangent intersecting outside of a circle, that's when we have this particular theorem. If a secant and tangent share an endpoint outside a circle, then the products of the length of a secant segment and its external segment equals the square of lengths of the tangent segment. With reference to this figure, it means that the secant segment, that is EC plus CD or ED, times the external portion of the secant segment, that is EC, equals EA square. Okay, please note down this particular theorem. We will see a few problems based on it in another 30 to 40 seconds. Okay, let's see a few problems based on this particular theorem. I'll do the first one, then I'll give you a chance to work on the second and the third. Let me call this as the first, your second and third. On the first, the tangent segment is 10, so tangent segment square equals secant segment, that is 5 plus x, times the external segment of the secant segment, that is 5. So 10 square is 100, 5 times 5 is 25 plus 5x. Further subtract 25 on both sides to get 75 equals 5x. Then divide by 5 on both sides. You'll get x equals 15. Okay, I hope this is clear for problem 1. I want you all to try problems 2 and 3. I'll give you exactly like 2 minutes from now, and then we will go over the solution. Okay, let's go over the solutions for problem 2. Here the tangent square is x square, and the external segment of the secant segment is 9, and the secant segment is 9 plus 7. So 9 plus 7 is 60 times 9 equals x square. 16 times 9 is nothing but 144. So I have x square equals 144. Taking square root on both sides, I get x equals plus or minus 12. I can't have a negative answer, so x has to be positive 12. Okay, I hope this is clear. On the problem third, we have the tangent, which is 15. 15 square equals, the external portion of the tangent is 9, of the secant is 9, and the secant is 9 plus 4x. Okay, let's simplify and get the value of x here. So 15 square is nothing but 225, and 9 times 9 is 81, and 9 times 4, which is 36x. So we have 36x here. Subtracting 81 from both sides, I will have 144 equals 36x. Dividing by 36 on both sides, I get x equals 4. I hope both of these problems are clear. So let's move on to the next slide. Okay, this will be our last slide. Find each missing angle and arc. I want you all to try this particular problem, and I'll give you like 3 minutes, and then I'll go over the solution for that. Okay, you can use all the theorems, properties, whatever you have learned find each basic angle and arc themselves. So whatever you get, whatever arc, all these are the arc ST, you need to find SV and VW. Angles, you just need to find whichever the interior angles or the exterior, all the basic angles that you can think of. Just try. I'll give like 3 to 4 minutes and then we will go over the solution. Okay, let's take a look at the solution of this particular problem. Here I have TUR given as 124 degree. So I can find UV. I can find UV, which is going to be 180 minus 24, which is 56 degrees. Same way I can find UV or VS. UV arc is going to be congruent to VS, that's given to us, so that's also going to be 56 degrees. And we will end up having arc ST, that is 180 minus the arc UV, so this will give us 124 degrees. Okay, we got all the arcs, we will try to find the angles. Angle SVT, angle SVT is corresponding to arc ST, and from the theorem we have angle SVT equals half of arc ST. Arc ST was 124, 124 by 2 will give us 62 degrees. Then to get STV, STV equals 180 minus 90 minus angle SVT, which is 62. 180 minus 90 minus 62, which will give us 28 degrees. Then to find RSV, which is 180 minus 90, which is 90 degrees. Then SVR is going to be 90 minus SVT, which is, because we have a tangent here, right? So here TVR is 90 degrees. 90 minus angle SVT will give us SVR, which is 90 minus 62, that is 28 degrees. And to find angle SRV, angle SRV is going to be 180 minus SVR minus RSV. Sum of angles in triangles is 180. Using that we can get angle SRV as 180 minus 28 minus 90, which will give us 68 degrees. Okay. Then further, I think this should have been 62 degrees. Just let's check. 180 minus 28 minus 90, that gives us 62. Okay, there is a small error. So that is 62 degrees and that 68. Just let me make that change. Okay, now further going to the other angles that we see. Angle TUV. Angle TUV, this is going to be diameter because this is 90 degrees, we know that. Using that itself I have done all this work. I was able to do the first calculation because I thought this was a diameter, and this is diameter because this is 90 degrees. So this is 90 degrees. If this is a diameter, then this opposite angle to this particular diameter is even TUV. This is also 90 degrees. This is 90 degrees. I can same way calculate TVU. TVU corresponds to angle 124 degrees. Half of 124 is 62. So 62 is your angle TVU. And then we have VTU. VTU equals 180 minus 90 minus 62, which is 28 degrees. Because we had this as 90 degrees and this as 62 degrees, so I could find VTU as 28 degrees. Further, I have angle VUW. VUW is 180 minus 90 degrees, which is 90 degrees. And angle VUW. VUW we found angle VUW we found to be 90 degrees. So further we are finding angle VWU. It should have been VWU is nothing but 180 minus 28 minus 90 degrees, which is 62 degrees. And this is the measure of UVW, which is 90 minus angle UVT, This is your 90 degrees because of tangency over here. So 90 minus 62, which gives us 28 degrees. So this portion is 28 and this is 62. I hope you have solved all the angles and arcs on this particular problem. You can utilize rest of the class time to take unit 10 quiz, which is there on the hub. Okay, it's 45 minutes time and you'll have just one attempt. Okay, good luck with the quiz. I'll see you in the next class.